Hello everyone, how are you? I hope you are doing well. Now this class is related from IP header, which is very important class, and we have discussed previous some things about IP. Now this will be the series of chunks, so don't worry, we will provide every point here. Clear? So let's start. This is a picture of IP header format. Clear? In the same manner, like a TCP header, this is as well. But something is different, so we should revise the previous concept. And do you know about OSI layers, that is application, and TCP IP suite as well. Application layer, presentation layer, and session layer. From these layers, the data is in a raw form as a bulk. Clear? Then it come at transport layer. Because this is a bulk in chunks, so we will provide in small chunks. We will provide in small chunks, and these small chunks is known as segment. And in this segment one thing is written, that is header. This is a field of header, because how can I recognize this is the data, this segment is related from this data? So we should decide, otherwise it will be mismanaged. How can I count the data? Our data is complete. So for the facility and for the convenience, and to provide the best way to communication, and to provide reach out each and every data, so reliable, trustworthy, we need some information about each segment, otherwise we cannot reassemble, we cannot count how much data is received, how much data is passed out. So that in this region we provide header, attach header. So we are providing header, that means we are encapsulating the header. Here when you attach the header, this process is known as encapsulating. Clear? And when other machine receive this data, this known as decapsulating. Clear? The same things, so don't worry about this. Now when this segment, this is a segment, clear? Now this segment come at which layer? Network layer, where IP is work. Here TCP and UDP work. Not only IP works, but IP attaches the header. This is the point. IP attaches the header. Suppose if anybody asks which protocol at network layer encapsulate the header, that is the simple point. This is a IP header. Now at which layer? At transport layer, which protocol attach header? TCP. If you are talking about TCP, then TCP, otherwise UDP. Clear? Now network layer, at network layer we call this, if we attach in segment header, that this header is known as IP header, and then this known as packet or datagram. Clear? some resources says datagram, some says packet. Now there is a region packet and datagram. Do you know if this is the symbol, whatever you want and what you want to express, this is the meaning. Somebody believes only this is the packet and define this way definition, and somewhere suppose that this is a datagram and they have a information about in this way. So it is not matter of defining the things, but you should have a understanding about at network layer the packet, datagram, whatever you want. This is the things here. Segment of data of upper layer attached with header is known as packet, and if you want to say datagram, can you say, it is your choice. So here this will be and this will be clear packet. Now this packet want to go, so it has IP addresses, clear, to go another user, to go at another user. Now this header attach more information because it is not the same things for whatever we have defined in at transport layer, because this is the common point, because this is a limited. This protocol is called on host to host protocols in an internet environment. Clear? Internet environment. And at local network protocol to carry the internet datagrams to the next gateway to destination host. Clear? One to other. This is another. Clear? Here. And you should have information at transport layer. We were talking about reliability, but at network layer we are not provide reliability, because we already have provided reliability, and we provide sequences, and we provide the numbering. So in this layer, at this layer, we are not providing reliability. We are not talking about reliability, flow control. Clear? We are not providing sequencing and other services commonly found in host to host protocol. The internet protocol can capitalize on the service of its supporting networks to provide various types and quality of services. Which type of priority we will use, this is taken here. So first we should recognize the header. Here each layer represent 32 bits. This is a first layer, this is a second layer, this is a third layer, this is a fourth layer, this is a fifth layer. Clear? And each layer represent 32 bits. This is a sixth layer, but this is included more layers as well. So this is field we will not use generally. Clear? Now here the important point, this is version, internet header link, that means size of header here represented, type of, these type of information is only a representation of some meaning, meaningful representation of it in this header, as well as TCP header. Every bits it represent some meaningful point. So it is not an alphabetical meaning. This is only a as we use this binary digits as a meaningful content. Clear? So version, internet header length, type of service, total length. Total length means this provide the information about packet. Clear? Now identification use generally we, because there is the case, because sometimes in at network the size is increasing, so we should divide in, because if this data, this packet is heavy and other devices buffering and it is a full, so we should manage with the help of there is congestion, then we should divide in parts. So to recognize the parts we generally use identification. So flags is the more important point. Fragment offset, time to leave protocol. These identification flags and fragment just as a only we use generally we use to recognize the packet. Clear? Time to leave protocol, header checksum, and here we use header checksum because at TCP at transport layer we used whole checksum for because whole data, but here this is checked, already checked, and this is already verified, but header is not verified, so we use header checksum. Clear? Source header, destination IP address. Clear? Options and padding as well. This is the whole information about IP header. Clear? Now we will provide each and every point. So in this video we will provide only information about version. Clear? Then we will provide internet header length. Clear? Now look at version. This is a field of 4 bits. This is a field of 4 bits. Clear? This is a so such that this is a representation. Which type of version we use generally? We generally use 4 and 6. Clear? So this is the representation of version, and here 4, here 6, but here 4 bits only. So how can I represent these things? So first we should try to understand. Clear? Now in this way we can suppose this is a 4-bit field 0 0 0. Now how can I write 4? Here 1 2 4 8. Clear? We can represent. Now if you want to write 4, then this is a 4, so 0 1 0 0, this is known as 4. If you want to represent 6, then how can you represent 0 1 1 0? Clear? This is a 6. Now the question arises, why we should use this 4 and 6, and why we do not use 5 as well? So in the on the basis of resources we can, this is only significant digits. In the networking we generally say this is only significant digits. Clear? So we by so this way we are using IP version 4 and IP version 6, and this is very helpful to provide that means need of IP addresses. And when we were using IP version 4, that means 32 bits only, and IP version 6, that is 128 bits. Now 32 bits were not completed, because for more if our population is increasing and devices will increasing, how can I provide how many IP addresses we can provide. So we have completed with the help of APIPA and NET as well, but we cannot provide at all for all. But this is I think if a population is increasing in future, then this IP version 6 will be very helpful. Clear? So these type of representation, that means in at any, if you want to hear one, if you think that if your population is increasing, then you will write how many types of version you will use. Generally 8, 4, 4 to 6, 6, 1, 7, 8, 7, 15. So 15 versions. So how many? That is things 15 bits, 15 version. IP version 4 has 32 bits. This has a 120. This version have more bits. That means each particles you can provide IP version, IP. Clear? So generally this is a significant, so we use, and our according to our syllabus and according to our computer networking. And today you have only in this era you have more use 4, and generally we use 6 for a big purpose. Clear? But there is conversion available for this. So this is a 4 bits. Why we use? Do you know why we use? To indicate format of IP header. So we can say that we were using version field to indicate format of IP header. ठीक? Okay. This is a representation only. Now in next video we will tell you about internet header length. Clear? Now in this video we can provide, because this is a very simple, and so we should provide this internet header as well. Now this will be, here we can say that internet header length on the basis of TCP layer we have provided about do, that means data offset. So it is also something like that. Clear? Now here total length is also representing, but generally overview here we are providing internet header length. Calculate the each row here 5, 1, 2, 3, there are 5 rows, so 5 into, that means 20 bytes we generally use. Clear? 5 into 4, that means 20 bytes, because 4 bytes each row, so 20 bytes. This is a header length. So indicate the size of IP header in 32 bits words. So this is used to indicate size of header. Size of header. Which type of header? IP header. Clear? So this is only indication. There are 5 rows, and that means 20 bytes, and because there is a field of options, so generally we use a variable field. If we use 0 bytes, then 20 bytes, so minimum header length is 20 bytes, and maximum will be 20 plus 40, this will be 60 bytes. Clear? This will be 60 bytes. And if you want to find out the row on the basis, then we should divide how many 4. So if you divide 60 by 4, you will get 15. So 15 row is available. Then 15 row will be available. Because 0 to 40 bytes this is. Clear? This 0 to 40 bytes. So this is the whole information about internet header length. Now we will in next video we will discuss type of services. If there will be time available, then we will define total length. Clear? So wait and watch for next video. Thank you guys.